Our next step will be predicting and establishing a standard of evidence. Specifically, we'll use one of these hypotheses to make predictions of what sample means would reasonably happen if only sampling error alone was acting. Now notice, it might seem reasonable to take the alternative hypothesis and make predictions from that, but it will be very hard to discredit the alternative hypothesis that the mean after treatment is not equal to 100. In science, we try to falsify theories or falsify hypotheses. That's the only way we can make good inferences. So we need a hypothesis that we can discredit. And the null hypothesis makes a very specific claim that the mean of a population treated with ginseng will have a mean of exactly 100. And we know what types of sample means to expect if a population has a mean of 100. We looked at this with our little sampling demonstrations. We saw what would happen if we stuck 16 people in a sample and just took their mean. In fact, this drew out our distribution of sample means. And without ever doing a sampling experiment, without ever making our sampling distributions, we knew that this distribution of sample means would be normally distributed and would have a mean, that is, the mean of a sampling distribution of sample means, that was equal to whatever population we're taking samples from. And we also knew the standard deviation of the sampling distribution of sample means, that is, the standard error. Without ever doing our simulation studies, we knew the characteristics of the sampling distribution in this context. And to figure out these characteristics, we only need to know the population mean we're trying to estimate. In this case, it would be 100 if the null hypothesis is true, has a standard deviation of 15, assuming we didn't change the standard deviation with our treatment, an assumption we'll come back to, and we needed to know our sample size, samples of size 16. With these values, we can populate the characteristics of this distribution of sample means. Specifically, the center of the distribution of sample means would be exactly 100, and the standard error would be 15 over 4, or the square root of 16. So, with these characteristics, we can draw an x-bar axis on this distribution of sample means. Remember, the shape doesn't change, we're simply adding a new axis. And this gives us an idea of what types of sample means we would expect to get if the null hypothesis is true. And notice that again, we didn't have to do a sampling experiment. When we had a population, took samples of size 16, then z-scored them, we simply ended up with that unit normal distribution. So, this distribution of sample means was known even without knowing anything about the population. That is, we simply had to assume the null hypothesis was true, and we can know what sample means we're likely to obtain. Now the question of our standard of evidence. Certainly if we got a sample mean at 190 or a sample mean at 40, any of these sample means that are really far from 100, given the scale of x-bar we can see here, would lead us to not believe that our sample was actually coming from a population centered at 100. But the question is, where do we punctuate this distribution? Where do we say samples do not support the null hypothesis? Remember, the null hypothesis is claiming something very specific, that after we treat that whole population, the sample mean we're taking is coming from a population centered right at 100. I think we can all agree that a sample mean of 160 or a sample mean at 40 wouldn't support the null hypothesis. But we need to be specific about where we draw the line. How extreme, that is, how far from 100, would a sample mean have to be for us to no longer believe that the null hypothesis is a reasonable explanation? Remember, we're just taking one sample from all the possible samples we could possibly get, and we're going to have to use that sample to decide whether it's reasonable that it came from a population centered right at 100. How would you draw the line? Where would be extreme enough for you to stop believing in the null hypothesis?